Let's get started. So the idea and the sort of impetus behind this talk, and you might have sort of noticed some of the links that were shared on the Meetup page, is around this concept that with serverless, specifically with web applications, the whole idea of having an application server is maybe on its way out. And a part of this talk is to, maybe convince you a little bit that that is sort of true, and go over maybe the architecture a little bit to give you a sense of why it's going in that direction, and why that's not necessarily a completely bad thing. And the way we'll sort of approach this is starting off by looking at what the world looked like prior to serverless, which is pretty much what it looks like now, and how it's hopefully going to be soon. I noticed that there were some front-end people in the crowd, and a little bit of this talk is sort of addressing, I think, the so-called mythical divide, I'd like to think, between front-end and back-end, and why with something like serverless, we have an opportunity to sort of break that down and make it so that you've got true full-stack developers. Because a lot of times, you'll hear people go, "Oh, I'm a full-stack developer," and somebody else goes, "No, not completely. You can do some things on the back-end, maybe some things on the front-end, but you can't do everything." And maybe that is changing with serverless because you're sort of taking away the infrastructure bits of it a little bit, and we'll go over that today. The other aspect we'll try and do is give you a sense of what a real web application looks like, a full stack application looks like in serverless, and the specifics of it. We might not jump into the actual steps of building it out. We'll go over sort of the code at the various checkpoints. The bulk of it really is a part of our tutorial, which you might have come across, but I'll talk about that in a second as well. And so let's get started. As I was sort of saying before, application servers have been sort of the defining aspect of web apps in the past, and this is a little bit about us really quickly. We run a fully managed CI/CD service for serverless. Again, the whole idea being that we're moving towards managed solutions. Why don't we have a managed solution for CI/CD as well? It shouldn't be about you figuring out Jenkins for half a day and maintaining it for the rest of your life. And with Seed, we're hoping that people just drop in their serverless framework projects, and we just sort of take over from that point on. The other thing that we do is this open source guide. It's called Serverless Stack, which we launched last year in February, and it's sort of incredibly grown over the last year. We now get nearly 2,000 people every single day, 30,000 people a month. We've got a ton of people on our newsletter, and we tend to get tweets like this or feedback like this fairly often. This was from, I think, yesterday or day before. And what we really try and do in the tutorial is we try and go through the actual nuts and bolts of building a full stack application on AWS, specifically using serverless. A lot of our readers are front-end developers. We do have a lot of back-end developers as well. But a lot of front-end people have sort of latched onto this because it gives you this notion that, hey, if I know JavaScript, I think I can do everything. And the tutorial hopefully drives that point home. And so the talk today is basing a little bit off of what we've seen in terms of that trend when we talk to a lot of developers that have used our tutorial or some of our services where they genuinely feel empowered. And so again, this talk is like taking a step back, looking at why is that happening, and is there something new about that? So let's get started. So this is kind of how the world looks like, and for Frank and I, we've been on AWS for a decade, but we've been building just products and services for as long as we can remember. I'd say like 15 to 17 years or so. We might look a little on the younger side, but we're a little bit older than that we sort of come across. We've pretty much been building for as long as we've been able to. And this has been sort of the three-tier architecture. This has been really the pattern that we've grown up with. Like, we've seen this all the way throughout. And in fact, 10 years ago or 15 years ago, if you had asked us, hey, what do you guys do at your company? I would go, hey, I'm the front-end guy. I live on the client. And he's the back-end guy. He lives on the app server and this thing called MySQL that I never want to touch. But the way we interface is he just tells me some APIs. I go call them. If it doesn't work, I bug him again. And at some point it works, and our users use everything that they see from me, and every time something's broken, it's his fault. But this has sort of been the very standard divide. It's just something that we've taken for granted for so long that that's just the way we think about things. There's a client layer, there's an app layer, and there's sort of the DB server. The app layer is really just made up of, again, these days, if you're more familiar with Express for Node, Rails, obviously for Ruby, Django for Python, and many other sort of ones for Java that you might have come across as well that we're not too familiar with, but obviously exist. And this model has sort of lent itself, I think, to an interesting pattern, which is the app server where your Express server or whatever runs, where you would typically, in the past, you would have SSH'd into, would do everything. So it would provide the API. It would handle all requests, so it doesn't matter who's dealing with what part of the application or service within your application, within the architecture of your application. They are talking to the app server every single time. It handles file uploads, and typically the way that works is, yeah, you dump it on some temp server somewhere, or the temp directory somewhere, and then you move it off to, let's say, a file server somewhere or whatever. Or it lives there for however long you can sort of scale that model to. It authenticates users, so this is, look, you never get to touch the database on its own. You always talk to the app server. The app server makes sure that you have the right permissions to do it. So all the security stuff kind of happens here as well. If you mess up on not applying the right patches and making sure that this thing is up to date, I sort of remember this when we had first started. And again, this might be kind of silly, but when we first started, I just remember like bringing up an app server for the first time, just bringing up a server for the first time. And within about 10 minutes, I realized, oh, we're getting hacked. Like there are people making connections to this. And obviously, like this is just one of those things that you sort of go through. You have to make sure that these things are secure because this is the one that is being exposed to the rest of the world. And then after a little bit of time, you start getting these things where I would go, hey, Frank, we need to run this service to make sure that the profile images of all the people that are uploading their profile photos are, of the right sort of size and optimized or whatever. And so he'll write sort of a cron job. And then it'll be like, oh, we need to migrate some data over, and we need to migrate some of these other files over or whatever. All right, we'll write a script, and that runs on there as well. And then you get into this pattern where almost anything and everything that you do runs on this thing. So anything in production that you're ever going to do that is not related to data or storing data, that is, you just do it on the app server. I don't know how many of you guys are sort of familiar with, like, at some point there was this pattern with object-oriented programming where you get into this sort of God class thing where there's this one class that ends up doing everything after a while. Like, it's this gigantic file because you just don't have a better place to put it. And I think that is fundamentally the issue with this app server, is that when we go back to this model, you can't shove stuff into the client, at least in the past. That didn't make any sense. The client can't talk to the database directly. So the only logical place to put it would be the app server. So the app server just begins to bloat. And that has an interesting consequence. So when it comes to scaling this guy, it just isn't this case of like, oh, I can just clone him and I'll scale him. No, you can't quite do that because you've got all these other tasks that are probably running on there that maybe you haven't thought about recently and that are probably going to break. And so you get this gigantic monolith that you have to take care of at some point. So again, it goes from this really neat 3-tiered architecture, seems really ideal, to app servers doing everything pretty much. And then there came a shift at some point. And this was, I think, with Heroku really, where they introduced the idea that, look, we're not going to let you SSH into the app server. You're just going to dump your Express application, Rails application, whatever it is, onto this, and we'll handle the stuff from there. And so then you had this pattern of, oh yeah, all right, so the uploads are probably going to go somewhere else. If we've got a full text search service, that's probably going to live on some other service as well, or some other server. And the app server now is sort of coordinating, between all of these services. But the one pattern remained. The app server was the gatekeeper of everything. So this is the guy that stands in front of everything else that, again, your clients just cannot get to their other resources, these other resources, without going through the app server. And what's sort of interesting with that, and this is something that we've been exploring with our community with the tutorial, is that this is really where I feel the divide is in between a front-end developer and a back-end developer. A front-end developer is somebody that cannot get past this divide or can't get past this gate. A back-end developer is somebody that apparently has the Linux jutsu or whatever, to do the stuff past it. And that's again, back in the day, if you'd sort of asked me, that would have been Frank. You've got like I'll like look over at a screen. It's like a bunch of screen sessions open, but God knows what he's running, and I have no idea about these things. But yeah, it was just this. That was it. Like if you knew that stuff, yeah, maybe you could get into full stack sort of development. Like maybe you could get into the point where I can meaningfully build an entire application. Because otherwise, it's this concept of, hey, I'm a guy, I know how to do sort of a lot of front-end stuff, but I need to find a back-end developer to help me. I've got a great app idea or whatever it is, but I can't quite do it. Maybe I can like piece some pieces together or put some pieces together, but I need to find a back-end developer. And I think this is fundamentally the reason why, is that there is this whole idea that this guy sits in between, and you need to learn the ways of this guy to be able to talk to anything meaningful. And that also creates this other really sort of weird thing, which I come across and I never quite understood, is that we sort of look down on front-end developers sometimes. We're like, hey, they don't do all that much of an important task. Sure, they're like pushing some boxes around, making sure they don't error out on Internet Explorer, but really, they're not doing anything. All the heavy lifting is back there, right? Like it's leave the heavy stuff to us. And Frank didn't quite say that, though. Maybe he did think it at some point. But you guys talk to the users and do sort of the silly stuff. But again, and this is sort of where I think it's going, is that we're going in this direction of breaking down the barriers and almost making it so that if you're again able to write just functions in general in Node.js and whatever other serverless languages there are out there, you should be able to do the whole thing, because these pieces aren't all that important. And I'll give it over to Frank to show you the future.
Yeah, he was like, do you want to do the beginning or the after? I'm like, no, I'll do the after, because I'll start crying when I do the. Because I used to be a backend guy, and since like we started working in 2007, and we've been running on PHP forever, we never want to switch until like PHP, the footprint for each request is way too long, and we're like, all right, we need to look into Erlang. This is the hottest thing back then. And we stayed for Erlang all the way till like 2015. And I never want to switch because, like new switching takes a lot of time, and serverless is actually the first time we made the switch, we made the jump, where I felt, oh, this actually doesn't take any work to switch over. And I'm going to go into detail why that is the case. Hello? Okay. All right. Now this is the new model where we're looking at pretty much before this point. Oh, I have the pointer right here. All right. Before this point, it's what we call so-called front end. Everything here is the back end. All right. And now see from this one, you might see a lot of terms that you might not recognize. This Cognitos, IAM, Lambda, pretty sure everyone knows about. This Dynamodb, this is Elasticsearch. Every piece is a service that Amazon offers. And what is taking the center stage right now is it's kind of like your front-end React app, or pretty much your front-end app. And this app initiates all the user requests. For example, it talks to Cognito, and this is a service offered by Amazon that does user authentication. And you can create a user and password directory where stores, you can set some policies, say, hey, you need a password that's longer than 8 digits or 8 characters, and you need to have some special characters. You could hook up your Facebook integration, your Twitter integration. If you're enterprise, you can hook up your single sign-on. And what Cognito does is, it doesn't matter who you are. You might be Frank on Facebook, you might be Jay on GitHub. But the moment you're authenticated with Cognito, they give you this authenticated Cognito user ID. So you're this Cognito user from this point on. And any AWS service you talk to, you are this user. You're this Cognito user. And then, so once your user is authenticated, for example, I give you an example. Let's say user come to your site, they go to your login page. There'll be a couple buttons: login with Facebook, login with Twitter. You click, they can talk to Cognito. You'll be like, hey, this is so and so on Facebook, and they're like, okay, since this guy's authenticated, I'll generate you a Cognito user ID that you can use to talk to other services. Lambda is the pretty much was replacing our previous app server logic, where you literally just write a function that could be in Node, in Python, in Go, or Java. You just literally write a function. We are going to go into detail about what the function looks like, but it's really just a function that takes a couple parameters, has a return value. You just give this to Amazon, and it's like, hey, here's my function. If somebody make a request, Amazon is going to spin up a container, depending on the language, to spin up a Node container or Python container, run that code, and then give you back the return value. And you're not getting charged for from the container that's spin up and to the time where the container dies. You only get charged for the fraction of second, hopefully it's a fraction of second that the request is being processed. And it's prorated to 100 ms. So usually a request, for example, like a keep alive request, which shouldn't do much, you should run finishing within 100 ms. You get charged for a fraction of a cent. So it's like really, really cheap. Okay, that's pretty much Lambda. We're going to detail after. And S3, everybody's familiar. S3 is just a file system that they store data. Dynamodb is their NoSQL, almost key value pair data storage. Elasticsearch is just their implementation of search. This piece is the mythical part, is IAM. That's what's scaring a lot of people away. Because everybody you read online, Lambda is super easy to get started. And the moment you jump into the AWS documentation, they're like, oh, you need to create an IAM role for this, IAM role for that, you need to create an IAM policy. I hope by the end of the day, I can explain to you what IAM is, like in very simple term. IAM is a service that oversees all the Amazon services, and it does two things. It creates a bunch of roles where other services can use. I'll explain in a bit more details after. And for each role, there are two important, really key information: is who can assume this role or who can act as this role, and what permission does this role have. And put into the context, when a user log in with their Facebook or username and password from Cognito, the way you set up Cognito is like, okay, there are two types of users Cognito is going to give to you. One is authenticated and one is unauthenticated. And you need to set up what permission does the authenticated user have. Right, in this case, you can see we want the user to be able to store or fetch data from S3 bucket, from maybe to invoke some Lambda, and maybe to run some search queries. So you pretty much have to draft up a very detailed IAM policy saying, okay, for any user that's authenticated with Cognito, he can do this, access this, this, and this. And that's it. Same thing for Lambda. When the Lambda runs, Lambda need to go to IAMs and say, hey, give me a role that I can use and tell me that what permission I have. In this specific case, Lambda only needs permission to access DynamoDB. So you probably create another role in IAM saying, okay, this role can only be used by Lambda and it can only access Dynamo. So it's really like a really simple access management tier where you just create a bunch of roles that different services can use. Each one says who can use me and what permission I have. That's pretty much what IAM is. So with this model, ideally, you can have set up a very secure model where you log in, and a logged in user, you can specify what do they have access to. They can have access to a specific S3 bucket or a specific file within this bucket. They have permission to invoke certain Lambdas, but not others, and run certain queries, but not other queries to Elasticsearch. The reason, it sounds very simple, but the reason it's fairly complicated when you start setting it up, because Amazon allows you to have really granular control over what permissions to have. So the permission model can be really intimidating, but the idea behind it should be fairly straightforward. We will go into some examples of how to set up the IAM roles. Any questions at this point? I think this is the most, like, the slide with the most like new terms and.
Yeah, just a quick bit to add. I think conceptually, again, like as sort of maybe an outsider to backend development, the way I would sort of think about this is, in the 3-tier model, your app server was sort of, again, like the gatekeeper. And as long as the actual gate is locked well, you're fine, right? Or at least that's the thought, right? Because everything goes through that guy. So as long as the locks are all right on that one and not being cracked, then you're OK. But here, the model is a little bit different. The client is talking to all these different pieces. And so the point of entry is now split up. So it's not that one big guy. It's all these different services. And the coordination between Cognito, user pools, which Frank will sort of talk about, and the IAM bit of figuring out who has access to what becomes a little bit more key. Because, again, all of these guys, you're talking over HTTPS, most likely. And, again, like there are more points of entry on some level.
Right. Right. Oh yeah. The question is, how does actually Lambda work behind the scene, and if it's actually spinning up a container behind the scene, is it fast enough, or how does it work? Right. Okay. So first of all, Lambda, there are some configurations you can add where you can say, oh, this Lambda, I want to how much memory to assign to it. And depends on how much memory you assign to it, it will give you like a container with that amount of memory, but similar amount of CPU, as in the more memory you give, more CPU it gives it. So the moment, let's say, a user comes to your site, they make an API request, and the API triggers this Lambda. And first thing Amazon is going to look into, like, is there any container that runs that? First of all, each Lambda function has a unique container tied to it. As in, for example, you make a user come to your site, they make a get user API call, and they're going to look into, okay, is there any container that's already running that's having the function get user API in there? If there isn't any, they're going to spin up a new container, and if it's spinning up a new container, of course, that will be a couple seconds. I think Amazon's working on it right now. It's they might maybe manage to under a second, but you get a couple hundred ms to a couple seconds of what they call cold start. After you finish handling your request, Amazon's going to keep the Lambda container there running for roughly 15 minutes. And so if there's another request coming in after this request, they're going to reuse the same container so you don't get hit by the cold start. But let's say now, while you're handling that request, another request comes in, and Lambda is going to look at, hey, there's containers in use already. I need to spin up another one. So for the second request, for the second concurrent request, you get hit by the cold start again. So that's kind of how it works behind the scene. Yeah. I don't think Amazon explicitly say the algorithm behind it, but that's from benchmark. That's pretty much what people are seeing. Cold start used to be a big issue in the community. I was hearing this talk by Amtrak. This is the kind of like the GO train comparison in New York City, right? They shifted everything to Lambda, and so when you get on the bus or get on the train, when you tap your card, they're gonna make a request to the API, which triggers a Lambda, and they're gonna say, oh, okay, how much balance this user have, and what's a remaining balance. In the morning, like around like 6 or 7, the first batch user get on the train, their tapping card is always a couple seconds slower than the other customers. So yeah, so 6 in the morning, 4 p.m., that's when they get hit by the cold start issue a lot. But overall, it's not that big of an issue. So because of cold start, Lambda is not really recommended if you have time-sensitive APIs. Let's say if you're making a gaming app or like a trading app, financial app, might not be the best choice. But if you make like a social app where timing is not so critical, this is a perfect use case for that. Yeah, does that answer your question?
Yeah, that's great.
Cool. Thanks. Yeah. All right, just to quickly summarize. So like Jay mentioned, now the client, it may be your single-page app. Now it's the center of the stage. It coordinates all the services. You can talk to it doesn't have to go through the app server anymore. You can talk to the individual Amazon services directly. Everything's fully managed. For the Docker container that's running the Lambda code, you never need to patch the server. You don't have to worry about scaling. So everything's fully managed by Amazon. Yeah, Lambda is a piece that's glue everything together. This is a very simple use case of Lambda in this case, which just handles the API request. But Lambda can be used in many, many other ways. For example, when a user uploads a file to S3, you can have a Lambda that's listening to their, let's say a user can upload a profile picture, and you want to resize that to like 200 by 200. What you could do is you can have a Lambda that runs either ImageMagick or some imaging library that's listening to image upload from the S3 bucket. So the moment user upload a file, an image, Lambda gonna get triggered. You're gonna pull the image from S3. You're gonna resize it and upload back to S3. So now the user's images are all like sanitized. Dynamodb, if you want to, let's say, send out an email when the new user sign up. So you see you have a user table in Dynamodb, and now a new row is created for the new user. You can have what they call a Dynamodb stream. That's almost like, what do they call it? Almost like a binary log stream in MySQL days, where you can tie a Lambda function that's listening to anything that's happening in Dynamodb. In this case, a new row has been created for the user table. You can get the user and then maybe send yourself an email saying, hey, this user just signed up. Yeah, so Lambda is like the magic piece that's gluing everything together. Even for Cognito, where users log in, if you don't want to use Facebook, don't want to use user and password system that Amazon provides, you have your own, let's say you're on like PHP or you're on like Ruby forever, and this is new piece of server you want to spin up to handle like a side project, but authentication, you want to reuse the same authentication as before. So you can actually hook up a Lambda that handles authentication, where when user log in, and Cognito is going to trigger Lambdas like, hey, you help me to authenticate this user. Lambda can talk to your PHP or your monolithic server and say, hey, how do I kind of authenticate this guy? And after it's authenticated, it's going to tell Cognito where, and then you can authenticate the user. So Lambda can be used in any way possible. Yeah. So yeah, so Lambda is a piece that's gluing everything together. And this scheme uses a separate authentication provider. It doesn't no longer sit in your app server anymore. Everything is secured by IAM, the Identity Access Management, and everything auto scales. This is a key factor. A lot of people, but auto scaling is a little bit tricky because some people think, okay, Lambda it scales like infinitely almost. Amazon manages that, and they put my SQL server behind it, right? So my Lambda might scale infinitely, but your MySQL server might not. So that is a bottleneck. So if you want to achieve like true auto scaling, yeah. So maybe like you need to make sure some of the other services that they're all adopt the serverless ideology, pretty much. Yeah. All right. Yeah, this slide just talks about the flow. User authenticate on the client side, not talking to your Lambda, talking to Cognito service directly. They get signed in, they get a Cognito user ID, and any single service, other service I talk to, either Lambda or S3, they pretty much pass in that Cognito user ID in, and they're gonna check. Each service on its own is going to check, oh, does this user have permission to access the service? And everything is sent through HTTPS. Yeah. Anything to add? That's good? Okay. All right, let's dive into the code. This is my favorite part. All right, for the Lambda, so we look at, this is the code we're looking at for how does a Lambda code look like. And for the context of this talk, we are going to use a serverless framework, which is a really popular framework where you can deploy your serverless functions to pretty much all the cloud, that is Azure and Google Cloud and OpenWhisk. Yeah, this this project, you can, serverless project, you have 3 key parts to it. The handler, which is the key, your business logic, where all your code is in. The serverless YAML is just a configuration file you're giving to Amazon pretty much to provision, how to provision a Lambda and etc. In this case, it's a node example, so there's a package.json. All right, let's look into serverless.yml. What this function, what this file does is a couple key things, right? We're deploying to Amazon. This code I'm writing is in Node and using 8.10. This is the IAM role I was talking about earlier. By adding this part, I'm only allowing this Lambda to access my Dynamodb table that's in my US East region. And it can access all the tables and everything in there, but it can only do put item. This is missing, I think this is missing one part where who can, so, okay, anyhow, behind the scene, what this is really doing when you deploy this project is Amazon is going to look at this part, it's going to create an IAM role saying only Lambda can use this role, and whoever uses this role can only talk to the Dynamodb table in this region, and you can only write to it. You cannot get, you cannot delete, you cannot update. You can only create new items over here. The reason a lot of people shy away is it can be a bit intimidating because a lot of tutorials online, they want you to follow best practice. I think you should never use star. Star means you can access anything under this domain. For example, if you just replace US East 1 with a star, that means you can access any Dynamodb table in this account across all the regions. We don't want that. We just want US East 1. Ideally, you want to put the name of the table that it has access to. And yeah, so lesser star, the better, more secure it is. And so that's the security part, and this is the actual function, right? My function is sitting inside the handler.js. It's going to be invoked by the API request when we do /post/create. It's going to call this when the post request come in for /post/create. It's going to invoke the create function inside handler.js. Fairly straightforward because we have a front end that's calling it. You want to enable CORS. And authorizer is AWS IAM, pretty much the cognito that's authenticating this. And this is the code. This is pretty much the Lambda code where it's really just a function. It takes event, context, and callback. Event tells Lambda how this is triggered. You know how we're saying Lambda can, in this case, is getting triggered by API request. It can be triggered by a Dynamodb stream, a file uploading S3. So all that information is in event. Context is how we're saying how a Lambda function can be configured to have certain memory, certain CPU usage, certain it has a temporary on local disk. All that information can be accessed in the context. And callback is at the end of the function, you pretty much tell at the end of last thing in your function, you pretty much call callback. That's the end of execution. You're not getting charged for anything that's after this point. This is how you get the user ID from Cognito. If you remember from this slide, after you sign in either through Facebook or username and password, Cognito is going to give you a user ID, Cognito user ID, that you can use to talk to all the other services. And that information is part of the event. And you can use this user ID as pretty much your user ID that's stored in your database or anything else. And this is an example for calling a Dynamodb table, and at the end of request, you just say, successful, I'm going to return an object back. All right, S3 upload. This is just a bit of security for the S3 part. Because the front end is accessing the S3 directly, you need to enable CORS, pretty much say cross-domain access. Again, for security, you can allow GET requests, put a bunch of requests, and maximum request time is 3 seconds. Sorry, is this in milliseconds or seconds? In the seconds, right? 3,000 seconds. You can further restrict it to, oh, my front end is under a certain domain. Only this domain can access its S3 bucket. Just a bit on security. Cognito, right? When you first create a Cognito part, you can say, I want the Cognito to create a username and password pool for me if that's what you want, or you can say, oh, create tie it up to Facebook, or hook it up to Twitter, or etc. If you decide to create a username and password pool, you can set a bunch of user attributes, saying your username, the email. I want the user to be able to log in using username only, or they can log in with username and email. And I can enable two-factor authentication. After a user sign up, they get either a text or an email about the code, and they need to punch in the code to confirm their sign up. All those is handled by Cognito. You just need some attribute configuration. You can create an app. Because Cognito, for this user pool, it can be used for the front end can talk to it, the back end can talk to this to authenticate user. You create an app client for the front end, for back end, just to manage them separately. That's for the Cognito part. The IAM we were talking about earlier. We kind of had a feel of it in the serverless.yml. In the serverless YML, this IAM role that we created is for Lambda. It's what permission does a Lambda have access to. If you go back to this screen, Lambda needs to access Dynamodb. That's why we only have a Dynamodb section in the IAM role. But this user, after they get authenticated, we need to assign them some permission to be able to talk to Lambda, able to talk to S3, able to talk to Elasticsearch. And this is the code that's actually creating the Lambda, the IAM role for the front end user. We are pretty much saying they can only access files in this bucket and under this folder. This folder is pretty much returning you, this dollar bracket is returning you the user ID of the Cognito user ID. So we are creating one folder per Cognito user, and a logged in user can only access files that's within their folder. And they have complete access. They can get, they can delete, they can update, they can do whatever they want within their folder. This is the API part. This user should also be able to invoke APIs that is in this region, and this is your API endpoint ID. So they can invoke any endpoint in this ID, pretty much. In this API. Yep, that's pretty much the backend setup.
Yeah. So just really touching on the one aspect that we sort of skipped here was the Elasticsearch one. We wanted to sort of keep it simple. Some of the, again, specifics of not using stars in a lot of areas. Again, we want to sort of keep it simple there, but you just want to make sure that these things are as detailed as possible. I think one of the interesting parts here, and something that gets overlooked because it sort of seems benign and sort of simple, is this little bit here. It's sort of saying that your front-end user has access to effectively their own folder, and you're not creating any of these when you're creating your S3 bucket. This is just how S3 sort of manages it for you. But in that, again, if we go back to this sort of what the newer sort of model looks like, because you're allowing your users to upload files directly, you obviously can't give them access to all of the files that everybody else is uploading. And so there's this neat little trick. And again, because it seems sort of simple, it's overlooking this aspect that we're moving the authentication / permission and roles aspect away from the olden sort of app server into the client, and it's being managed directly with this managed service that we're using. So each of these managed sort of services have their own way of working with the authenticated users that you have and figuring those pieces out. So it's almost like, instead of you doing all of the work in your app server to figure out who gets to do what, each of these guys is sort of responsible for their own individual bits, and you're just sort of coordinating how that sort of happens. So again, it was sort of a neat little trick that ends up being used, but a lot of times people sort of come to us and they're like, hey, I've heard about this Lambda stuff, this is all great and all, but how do I upload a file? Because there's a limit to, and we didn't quite mention this, but there's a limit to how long your Lambdas can run. So if you're trying to upload a really large file, that's going to time out at some point. And so it does not make sense that you're doing the uploads through your Lambda functions. And so that's one of the first things that hit a lot of people there. When you're coming in from the app server world, you're used to doing so much because you've got freedom to do pretty much anything you want, including SSHing into the box, right? So because you have the ability to do all that, when you come into the Lambda world, it seems really restrictive, or the serverless world seems really restrictive. But there's a good reason for that, is that we're trying to offload these key pieces off to their individual providers. So if you're dealing with a file uploads portion, that guy should be the one that's handling these things, not the app server. Like, you shouldn't be the one figuring all these pieces out. And so when we think about really what serverless is, it's serverless on some level is a bunch of managed services glued together with Lambda functions, where you're just getting complete freedom on how to glue them together, and you are managing sort of the access with the security layer being pulled out and the permissions and IAM layer sort of being pulled out. So you're sort of keeping track of who gets access to what. But again, you're just offloading it off. And as like, again, like a front-end developer, or as somebody that's worked in startups, you love the feeling when you just hand it off to somebody and somebody else deals with it. It's just like, as opposed to, you just sort of like shove stuff in the corner in your app server and one day it crashes and you're like, you don't know why it's crashing. But yeah, so that was sort of a neat little bit that gets overlooked. And there are pieces like that all over the place that give you that sort of level of control. And I think in terms of tooling, we're still early in the serverless world where we've made this, it's not simple enough just yet. And that's part of the reason why we have sort of the guide. But yeah, I think it's definitely getting there. And this model is really sort of interesting once you start wrapping your head around it. So now we'll move towards the client side, the more fun part. And there's this, prior to this thing, I'm not sure if you're sort of familiar with this, it's Aws Amplify is a front-end declarative style JavaScript library to help you talk to a bunch of AWS services on the back end, right from the front-end client. Prior to this guy coming along, and with some of our earlier versions of our tutorial last year, for example, was a nightmare. Like, you have to deal with the AWS JS SDK on one end, you have to deal with the Cognito JS SDK on the other end. You have to sign requests yourself. So if I go back really quickly, and we didn't quite touch on this because it's there's quite a bit involved there, but after you get a token, after you're done sort of authenticating, each and every request that is made to all of your managed services or resources is signed using a signing process called the AWS V4 Signature, and that is probably the biggest source of pain for a lot of front-end developers when they get into the AWS world, is that you sign these things and they never seem to sign properly for some reason. Because it's taking into account the entire request package as a whole and trying to figure out, is what we're sending from the client, does that make sense when we check that on the sort of IAM or the resource level? And again, it makes sense. Like, the security is sort of really, really important because we're offloading security onto the client, and everything goes wrong, when you offload security to the client. So, so that piece is now being handled by this guy called AWS Amplify. And Amplify is a relatively simple library which is just building on top of the AWS JS SDK, which is extremely complicated but very, very thorough. And that's one of the things that Amazon is really good at, is making things complicated. And as a side effect, they're also very thorough. But so the way you start off with this guy, and we left the search bit out of this because we wanted to keep it simple again. But again, if you think about it conceptually, what's going on here is all the services that Frank just talked about. So we've got the auth guy. So you set your Cognito region. We didn't quite talk about the regions. We're just assuming you're working in the same region. The user pool that you created, this is where all of your username and passwords, everything is sort of being stored by Amazon. You get an ID from that. you get, when you created an app client specifically, one of those steps that Frank was going over before, you get an app client ID, and then you get this thing called the identity pool ID. This is the one that is sort of pulling all the identities or pulling all of the user sort of signups that are coming in or user authentication pieces that are coming in, and it gives you a global ID that you can use everywhere. That's the ID. This service is the one that gives you the user ID that we used in Lambda. It's also the user ID that we use while creating this guy as well. So this is this Cognito piece. And then S3, you just tell them where the bucket is, what the bucket name is. The endpoints, just give him the region and give him the ID again, or the URL in this case. And we, back when Frank was sort of talking about the Lambdas, we created essentially an endpoint to handle post requests. And again, you might sort of go, well, where is the rest of the stuff in this? Again, I keep going back here, but where is the rest of the pieces in my app? I'm just posting stuff. But you can kind of imagine you would have separate microservices or separate services of the exact same style. So Lambda talking to Dynamodb, Lambda talking to something else or whatever. And you have all these different endpoints. Again, how you architecture them is up to you, and that's something that is probably a topic for another talk. But the idea is just that you've got these services, and we're just dealing with one here, but you would end up with a few others. So if I come back here again, you would have different endpoints here if you wanted to, or maybe you've got a lot of them in the same endpoint. Again, that's sort of up to you. But once you have this guy up and running, and the other part I should mention for folks that are not familiar with this funny logo, that's React. It's a fairly common single-page application framework. You can sort of use it on the front end with web applications. You can use it with React Native on iOS and Android. But it's fairly common these days, and so I sort of went with that. But again, the pattern here is that you've got the single-page app that is running as your client that is taking care of all these things. So how do we sign in a user? Now that we've created our Cognito stuff back there, the sign-up is really sort of straightforward. This is wrapping around the underlying AWS libraries or Cognito libraries to create this. So you sign up a user with their username and password, then they get an email or a text with a confirmation code. You put that in, you confirm them, and then you can authenticate them. And Amplify sort of manages the user session for you as well. So you don't have to sort of do the local storage or cookies or whatever to handle that for you. The sign out is in there, but I'm assuming your users are so loyal, they're never going to sign out. And then you go into uploading a file, because that's really it. Like once a session is created, now that guy is ready. So that client is now, or that user with that client is now ready to talk to whatever, as long as you've given them the right permissions. And so again, you just pull out this sort of storage bit from Amplify, and you're just giving it the file descriptor. You're giving it a file name. You're setting sort of the content type. And this is going to use, again, if we go back to, I'm not going to go that far back this time. If we go back to this guy, it knows, since we have authenticated the guy, it knows what this ID is. It then uses this ID once the file upload is being done to save it under that user's bucket, essentially. And so that's really this part. And there's another method here that you can use to upload just not necessarily to their sort of folder within the S3 bucket. You can just upload it generally, but this is the one that would send it into their bucket. So once this is stored there, you don't have access to it. If you sign up, you don't have access to my files, that is, and I don't have access to yours. And then calling an API. You import this API thing, and the sort of keyword posts here is coming from here. We define this one endpoint that we have. Again, you can have multiple endpoints if you've got multiple microservices. And you pass in an object for the post that you want to store. Now that I look at this URL is wrong, I think. That's /post/create. I'm not sure why I named it create back there. But anyway, so there's this. This is the API that Frank had created when he was doing the Lambda with serverless.yml, or in the YAML file, that is. And this guy is the one that signs the requests. And again, all of the guys are actually signing the requests, but this one more specifically is signing the request for your API that's, again, handled for you. This is not something that you have to delve into. In some of the prior versions, prior to Amplify, that's something that we had to do. You had to use some library and do it by hand, or there was some really convoluted way of using their SDKs that they would generate for you, which nobody liked doing. And then finally, so now you've got your app up and running. So up to this point, really, your app is working in your browser. So if you've used React, there's like a thing that it brings it up in your browser. There's like, it auto refreshes when you make changes and stuff like that. And so everything's working in your browser, and now you're ready to host it. And one of the ways to host it, and there are many services to sort of host these things because it's really, really straightforward. It's just a static file. And we're going to host it, in this case, with an S3 bucket. We're going to create a public S3 bucket as opposed to what we had done last time, which is for uploading files. We put a CloudFront distribution in front of it. You don't have to, but again, like if you want to have a CDN, you attach a domain name to the on Route 53 to that CloudFront distribution. If you want, you could have attached it directly, I think, to the S3 bucket as well, but that's up to you. And finally, you can turn on SSL with Certificate Manager, and they've made that a little bit easier as well. There are a few steps here, and again, you can use some other service for this, but this is relatively straightforward as well. And once this guy is up there, because these are static files, like they just scale forever, right? Like there's no, you should not have, no, you will, but you should not have downtime on your client. Of course, S3 does go down. It seems like a yearly or bi-yearly event now, but it does happen if you're on US East 1. And we never learn our lesson. Every single time, like every single tutorial I have, it goes down on US East 1, and the next tutorial I start is on US East 1. So, we're probably part of the problem. But yeah, so you just put it up there, and all you do, this is a part of the React thing that comes with Create React App. You just create a build package, and all this is really doing is just taking all of your JavaScript and taking all of your HTML and your CSS, packaging up them together, minimizing, applying a bunch of stuff. So it gives you this, like, essentially this folder, your build directory with all those files. You just dump it into your S3 bucket, and that's really just it. So every single time you have a change, you run npm run build. You do the sync command, the S3 sync command. This is using the AWS CLI on your local. You'll probably use another flag to remove some of the older things, but it's very straightforward. Once this guy goes up there, you're pretty much ready for prime time. Again, like I said, as long as S3 doesn't go down, your site will always be up. And that's sort of really it. It's I guess there's sort of two parts to this talk in some ways. Really, is the sort of code portion and this transition that we're seeing, and when we had first gotten into this, and I'll really get into this really quickly, but what you see out of this is after you've built this thing, you get this like really weird feeling where you go, wait, what is my point of headache? Like, what do I have to worry about when stuff starts scaling? Aside from my bill, what do I have to really think about? And there isn't that much. Is that if I go back to this guy, and this is, when people go through our tutorial, I think that is the sort of really fun experience for whether you're a front-end developer. Sorry, I have to go really far back. Whether you're a front-end developer, whether you're a back-end developer, once you build these things, it kind of hits you. Like you don't have to manage anything at all. Like they're pieces. Like if S3 goes down, you go on Twitter and you post and you do whatever complaining that you do. If Lambda or sort of Dynamodb goes down or something of that sort, it's the same sort of thing. Like those pieces are problems of, I don't know how much Amazon is valued at these days, but it's a problem of somebody of that scale now. And that is really what I'd want to sort of drive home, is that we've built applications in the past before where, like one of our first things was a service for Twitter, which would give you like a Facebook-style Twitter feed. It's sort of what you see now where it says what you have missed or something like that. That was kind of our feature. And that ended up on Twitter's homepage. We started getting a ton of these users, and for a good 14 days or so, I slept okay. Frank didn't, but for those 14 days or so, it would just we would be like, oh, I think we fixed it. It goes back up. 20 minutes, it goes back down again, and then we're like, well, all right, let's go out there, and you're dealing with this MySQL nonsense that you just don't want to deal with. But that's really just it. Is that like, ever since, if you've had one of those experiences, and we've had a few of them in the past, you get to this point where you become very cognizant of which is the part that's going to break first. Like I know that when I'm building an application up front, I'm not designing for, let's say, 100 million users up front, but I still know in the back of my mind that this is the guy that I need to watch out for. That this is the one that's going to sort of melt, literally, when something happens. And that's probably one of the better feelings with this, is that because we've taken the app server out where everything used to live after a certain point, the room for where you can shove the pieces that you don't want to think about or that you haven't architectured well is just not there. Like where would I make my mistakes now? Like I guess my Lambdas would be terrible, right? Like I could write bad Lambda code that just dies or whatever, but it's one function. So if I had a bunch of these, let's say like we went over the post creating sort of function, right? If that guy is failing, that's the only guy that's failing. Of course, people aren't uploading photos or posting anymore, but a lot of the other guys are still up and running. Like it's not like I can damage the entire system because we didn't architecture our stuff well. And so it not only does it allow you to make or have you make less mistakes, it's also that the areas where you would make mistakes are just fundamentally smaller. Like you could write bad code on your client. Yeah, that does happen. And like it'll probably kill somebody's browser, but it's not killing your systems. Like it's like something that you can track down and you can fix on your own. And that's really just it, is that once you're sort of done with creating a full stack serverless application, you can sit back and look at that and go, you know what, like I think I've got pieces here where from now on, I don't need to think about the infrastructure as much. I can go out and think about what my users are struggling with, like what are some of the issues they're running to. Again, that's not to say that everything is solved for you, obviously, as we were sort of going over in the talk. You need to be careful about what things people have access to, because figuring out what pieces or what resources your authenticated or unauthenticated users have access to is completely up to you. There are some issues between, and you can sort of think about maybe this is a topic for another talk, and maybe some of you guys have dealt with it, and maybe you can give a talk up here, where because there's so many connected pieces, you're not quite sure if there's an error, you're not quite sure at which step is this guy failing. And because there are all these managed services that are glued together, you might have issues of tracing these requests through the system. And observability can be a little bit of an issue. Because again, with if you just had an app server where all the requests were coming in, you could just SSH into the machine, pull up and literally just look at all the logs. Like you hold everything in place. So that sense of, maybe that false sense of security is sort of gone, where you don't have this one area where I can just like pop in and be like, hey guys, what's going on? Why is my stuff breaking? Whereas here, they're a little bit more spread out, and you need to have a good view of the system as a whole. The other part that I was sort of mentioned, and again, I didn't put it on the slides because we wanted the slides to be more positive, though I guess this is being recorded. The part the other part that sort of kicks in here is your Lambdas just start to grow. So with Seed, with the service that we run, we've helped quite a few companies, and we get a chance to see what it looks like when it's been in production for a while. So one of the guys that we've helped, they've grown their serverless essentially system or application to well over 30 plus services, and we're looking at like a few thousand Lambdas at this point. And so again, team of 15 developers, a ton of different environments. And so you start getting into this case where, there are a lot of Lambdas to deal with. And these are problems that I think us as a community will start to solve as we sort of move forward. You can just think about, not a lot of people have had this sort of scale of issues. So again, so not everything is completely rosy, but really the big part here is the headache is really just gone. And the more you sort of sit back and think about these things, we start getting into the situation where, like, yeah, you know what, maybe the 3-tier application server days are sort of behind us. The one question that you might have while looking at some of this stuff is that, hey, isn't the application server just split up into a bunch of Lambdas? And that's sort of true on some level. Of course, it's up to you how you sort of architecture them. And again, if you have sort of separate services, the Lambda isn't the key component in there. And because you just can't do whatever you want inside a Lambda, you won't get into this case where your app server does everything after about 6 months of using it or developing on it. And so that's sort of really it. What I wanted to end off is if this talk sort of gets you excited about building a full stack application, this is our tutorial. I'd have to warn you, and I'm being told repeatedly that it's very dry. It's 550 pages. The impetus behind this is when we first started looking into serverless, sort of as Frank was sort of saying, we would look at a ton of hello world applications or tutorials. And I would be like, all right, great. Well, but how do I do a file upload, Or how do I authenticate? and then you see the signature V4 thing, and you go, all right, well, this is a good trend. I'll keep an eye on it. And so that's what we wanted to do. We want it so that it's not so much so that you're going to go through this in one sitting, though it's up to you if you want to. It's more so that it's got all the pieces there, so when I do run into some issues, I've got something to look at. And we're beginning to get deeper and deeper into some of the architectural portions. One of the more recent pieces that we've added and that we're working on is how do you architecture large serverless applications? How do you deal with multiple services? How do they coordinate? A bunch of these ideas around cross-stack references and sort of deployment patterns around that stuff. And so the idea is not so much so that you're going to go through all of that in one sitting. It's just that there is a resource out there that you could lean on when the time comes, if sort of necessary. And the key piece about this that's really fun to me personally has been this idea that it's completely open source. So I know for a fact that we'll get half a dozen or so people doing the tutorial every single day, or doing various parts of the tutorial every single day. And so the moment something breaks, people are on our forums. Like we've got a discourse forums for this as well. People are on there immediately going, hey, I'm stuck on this step. And now we've got sort of a wealth of troubleshooting sort of scenarios as well, where people have had a chance to go through some of these issues, and they run into common issues that they can solve again. But that allows us to keep it up to date. So very often, and one of these pieces that we use in the tutorial might have an update that's broken something or whatever, and it'll get fixed relatively quickly. A lot of times by me, but I think the key part is this notion that we're able to keep it up and alive and well. Because if you were to buy a book, they don't mail you a book every time there's an update. Of course, there's a raffle today for a book, but hopefully they keep it up to date for you guys. Though they have online portions to them, so I'm sure that'll work out. But that's sort of the big bit for us, is that we like to keep it up to date. And the other thing that is scary and sort of fun for a lot of people is we're just crazy about screenshots. And this is one of the issues that we had with AWS when we went through it the first time. The console's a nightmare. Like there's just like, I don't know if you guys sort of saw this, but there was this little quiz going around where people were asking you to guess the AWS services based on their icons, and nobody gets them right. I don't know where they come up with this. I think that's where the machine learning is, They're generating these logos and those icons off of that. But anyway, the screenshots really is to really give you each and every step, like here, click on this, do this. And then we get pull requests where people go, oh, those screenshots have changed now, and we'll go update them. But that's that. And then the final bit, this is the sort of self-promotional part. Once you've got one of these serverless framework applications up and running, what we do with Seed is you just come in and you just point it to the Git repo that you have. And we give you these environments. We give you secrets for the build process. So every time you do a Git push, it'll be in there, and you can sort of promote them into production. And you've got essentially an ability to manage the whole thing. And again, if you start adding tons of these services, you don't have to go through and configure a Jenkins or write a build script and eventually start hiring these people that are just managing that when they would love to work on your application instead. So yeah, so that's what we do with Seed. We just give you this like completely managed serverless specific thing. And then yeah, and that's us on Twitter. And if you guys have any questions, we're happy to take them. Yeah.
Maybe if you, yeah, we have time. We have to be out of here before 9, like around 8, like we can start 8:30 mingling with questions. So I want to thank you again for doing awesome presentation. So what I would recommend, because manual is huge. I discovered this religion a year ago, and I have to apologize. I didn't use the manual at the time, but like this presentation can be a good way to go through the manuals and get it going. And you have them, you have us. You can pose the questions. We don't have a forum yet. Somebody suggested, but you can also start looking, like I was recorded in the first presentation about serverless, so you can get the feeling what we are about. And also another thing is like the fact. So if you go back to the first slide with application server, like one thing that I didn't see for the longest time, because we are engineers who focus on PCs and doing proper job and kind of knitting it and cutting at trees nicely. You didn't see, so the next slide after. So the big thing that happened, so when I'm the old guy, so I was there when application server started. It was IBM, WebSpheres, and the Corba application servers. The reason for security was a big excuse for introducing application servers. We were kind of, the theory was if they come over the HTTPS, then we switch the protocol to Corba, and then hacker is confused because nobody knows Corba. And then it became JDBC, so that was kind of protocol switching. So really now with the security, what Amazon did with those, you said most of the talk was about security. You have three kind of buzzwords to master, but every request is secure. And what happened also, like the only benefit I see from Corba all days was this ideal language where they describe the contracts. You got your services, so really all these APIs you have is rooted in the Corba ideal. And so everything is now HTTPS, so nothing stops you from talking to them directly. So it's just like interesting to tease the current status quo in IT, and because nobody, like it's like don't go to that room, you don't even question what's in the room. Like this was a good opportunity to challenge the thought and you can be productive. And also in the talk before this one, so now we are scaring with the details, but once you get in the problem domain, you will be surprised how little technology there is in serverless technology. Like last time I was preparing like what was chatbots, Alexa, like it was like 25% the code. The rest was just learning about voice first design. So your mind will be free for other stuff. So, but if your managers will digest those ideas, so.
I should just add the Corba bit that he was sort of saying. I remember the first time I came across it, for a good 3 years, I thought that was Cobra. I never dealt with it, but every time I would see it, I'd be like, huh, that's a cool sounding technology, Cobra. And then it turns out it has nothing to do with Cobras. But yeah, questions? Yeah. So the question is React required for the Amplify thing? I think they support Angular as well. And I haven't had a chance to look at, so Amplify is relatively new. Some of the AWS guys had a chance to, or like I had a chance to sort of talk to them, and they got in touch with us, and they're like, hey, you guys should upgrade your tutorial to use Amplify. And so it's been getting updated fairly rapidly. I'm not sure what else they do. The way we were using it with React was a little bit more manual in some ways. Like I think they've got built-in components that you can use. And I think they have that for Angular. I'm not sure what other pieces. I think it's very popular, so I'm quite sure they've got some other sort of. Yeah. Probably, yeah. Yep.
Just curious about like testing this as a front-end developer. Do you like recommend making like mocking the responses when you're building the front-end code and you're gonna call your Lambda function?
Is this specifically during development, or like you want like test it like unit tests or like integration tests when you're deploying them?
Yeah, like your CI/CD.
Oh, the CI/CD portion. Yeah, I think the way, again, it's I guess up to you on some level, but the more common one is they sort of do unit tests around just Lambda stuff. That's the sort of simple one, and I think the tricky part is you getting some of these credentials to be able to do this, but one pattern some of the people use is they would invoke the Lambda. So all these lines effectively mean they're talking over HTTPS, but you could invoke the Lambda directly, not through HTTPS. And so you can sort of mock that part on some level, so you can mock the request on some level. So that's sort of one way of testing it as well. Again, yeah, I think it comes down to what you end up using. For us, at least in our experience, we lean more towards using sort of the integration tests at the end of everything. We don't want to, when we write our test, we don't want to be thinking about what the underlying bit is that we're using. We're just going to treat it as like an HTTPS endpoint. Let's just hit that and let's see what comes out of it. And so.
Yeah, just for testing, just from a backend developer perspective, how people used to test is you mock everything in your local, right? If you have MySQL, you have Redis, you download MySQL on your computer, you spin it up, you spin up Redis, and then everything configured to local host, and you run your unit test, your integration test. For Amazon, for serverless, that's the biggest question people have, right? How do I mock like my Dynamodb Elasticsearch locally, right? And yeah, there are libraries that can help you where they have Dynamo local, they have Elastic local, I think. But I feel these days, right, people like you have internet connections, it's not like you don't have internet connection when you're testing. And the way AWS services work is you don't have to go into the console and spin up each service. And behind the scene, you can put all the in the infrastructure as a code, as this one template. And you can parameterize that as in, I want to spin this, create this entire stack, give them a file, give them a template file, create this in one account, and create the same thing again in another account, and pretty much use that account as testing. So you're guaranteed to have like one-to-one mapping to your production environment. So that's the way we have been doing stuff. Like we rarely just do mock stuff locally, but almost have like guaranteed one-to-one mapping, staging, QA, dev. Like actually each one of our developers have their AWS account, and we just give them a template. Each one has their own AWS account. And because free tier is generous, each account have their own free tier. They can just do testing, create entire stack of seed in a separate AWS account, do entire testing. And if they leave, we can just shut down the AWS account. Like everything is fairly automated.
Yeah, so that's, I guess, and this, again, maybe a topic for another talk, is that as you're adopting some of this stuff, you begin to, for example, if we go here, you're adopting the infrastructure as code pattern as well. And so what that means is that this entire stack that you're creating is, again, an automated stack that's specific for, you can say, hey, bring up a stack called dev, and then it'll do that entire thing for you. And it almost like forces you into that pattern fairly early, and because of that, you can bring up test environments and just tear them down whenever you want, and so it's an advantage with that. Any other questions? Yeah.
Most naive approach is to keep a Lambda as each Lambda in its own repository. It doesn't really scale. Also, whenever you think about the system, it's not just Lambda, it's not just code, but also templates or the description of the environment, right? So those things overlap in the most surprising and unpleasant ways.
Yeah. Yeah, so the question is, how do you deal with deploying, I guess, larger scale applications, serverless applications, when you've got a ton of different Lambdas, and what is the maybe strategy that you use when you are storing them in a repository and some things around that. I'll let Frank talk more about the deployment side. The one quick bit that I will sort of mention is just the patterns on the Lambdas themselves. So here what we're doing is we're saying, for this specific event, I want this function, this module.create or essentially handler.create function to deal with that specific request for me. But you can change that around. So you could, and one very common pattern, or a relatively common pattern that is they would just essentially funnel all the requests under anything to a certain path, doesn't matter what method it is, goes into your function, and the function figures out what to do with them. And so you have sort of different ways of, so a couple of layers. So you've got different ways of structuring your Lambda functions, right? Do you want your Lambda functions to handle single events? And that is the more recommended way on some level. Again, this is probably a really, really long answer, I guess, now that I think about it. But really quickly, the reason you kind of want to do that is because AWS behind the scenes is trying to optimize the cold start times based on the size of the package that you give it. So if you end up, and again, around a year and a half ago or so, if you were starting to get into serverless, what they would try and tell you, even the AWS guys, or one of the teams on the AWS side, they used to put their entire server in here. So they would take an Express server, like it could be a Django, it could be a Rails application. They'd put that entire server into their Lambda. So it's almost like, I'm going to take the application server thing that I used to have. Maybe I used to host it in Heroku before, but I'll put that onto the Lambda. And that ends up not being a great pattern for multiple reasons. One is the cold start issue. So the bigger the package is, the longer it takes AWS to spin it up. The other one is deployment times get slower. But of course, you get the advantage of like everything is in one area and you don't deal with a ton of different Lambdas. So there's a bit of a balance there in figuring out what goes in where. And then, so that's one level, so the level of the individual Lambda themselves. Then there's the level of the entire service. So in this case, we just have one function in the service, but you could imagine you've got multiple functions under this service. So maybe the post service has a create, it has a delete, it has a read, it has an update of some sort. And all of these guys live under this service, and it's up to you what you want to put into the service as well. So you could add as many functions as you want in here until you hit like a cloud formation limit, which is there's like I think about 200 functions that you can put in one service effectively. And so at that point, you're asked to sort of split it up. So again, if you go back, so there's levels of how you're doing your Lambda functions. There's levels of how many services you're doing. And then the final bit, this is essentially your question, is how are these services or these guys going to work inside the repository themselves? And the pattern that we found, so we've run across a couple of companies, including ourselves, now that we've gotten much larger. The question that you end up answering is, if I've got a service called posts and I've got a service called users, let's say, how much code sharing is there between those two services? Because if those two services end up being in different repositories, code sharing is a little bit harder. A trick in the case of a node people use is they have private NPM modules to sort of share some code. So say you've got some library that handles the request that formats them before they go out, and that is the same across all of your services. You would maybe make that a private NPM module. And so now you have the ability to have multiple repositories. But for us, that ended up being a little bit of a pain. And so the way we ended up splitting our stuff up, and this is a common pattern, is a combination of multiple repositories and a single repository. So we've got multiple repositories for services that don't share code. And typically, this is a service, for example, that like brings up our entire infrastructure. And I'll sort of let Frank expand on that.
Yeah, we take the multi-repository approach where we have one repository to spin up, like say our databases, one that spin up our build servers, and we have one repository especially for all our API code and all the cron jobs and etc. But all the APIs are grouped inside. Yeah, like Jay was saying, how we are looking at this is one service. And each service can have multiple Lambda functions. Some can be cron jobs, some can be handling the API request. And we are grouping the usage by services. So one repository can have multiple services. Each service can have multiple Lambda functions. For example, we have our one repo that have all the API, all the Lambdas handling our API, all the Lambdas handling our batch script, and all the Lambdas handling our cron jobs. They have different use cases. That's why they're broken into different services, but they're still staying inside the same repository because they share a lot of code. Yeah. Yep. Yep.
Are you able to do that seamlessly when you deploy?
And talk about the different stages.
Yeah.
Yeah. The way this is structured is how serverless is structured is because they are adopting the infrastructure as code. So all the infrastructure that's provisioning, this is template, and your different environment. Let's say you were mentioning you have your dev branch is being deployed to the development environment, and your masters, let's say, deployed into your staging environment, and you can later promote to like production environment. Each environment is actually a different set of infrastructure. They are almost different Lambdas. It's not different versions of the same Lambda, but they're actually completely different Lambdas. Each environment is a complete clone of each other. This kind of tie back to the way I was saying how we're doing testing right now. Each developer have their complete set of Lambdas. when they are promoting, what you're promoting is you made some changes in the code. So for every update, you can either make some change in your code, your app logic, or you can make some changes in your infrastructure. And it's a code as well. So you can change in one or the other or both. So the moment you promote this package or this artifact from development branch to staging branch, you're giving this template and this zip file of your code to Amazon, and they're going to make the changes in another environment. So they're yeah.
Yeah, I think there's because this is the stuff that we think about all the time with deployments. We can chat further, but I think the key thing, and maybe you caught this already, was that AWS allows Lambda versions, but because of this pattern that a lot of people want to adopt, where they want to have different environments in possibly completely separate AWS accounts, you can't quite use the Lambda versions or the Lambda stages as the way you would split your stages, because like your dev could be in a completely different account. And so what serverless ended up adopting, serverless framework that is, what they ended up adopting is that every time you deploy, whether it is to a stage dev or stage prod, you get a completely new Lambda, essentially. So you don't have, you're not promoting between versions of Lambdas. You're essentially promoting between different environments or like different AWS accounts on some level. Yeah. So that's the way. And again, yeah.
But at the same time, you have production everywhere. Like before, the problem when I was kind of younger was having machine staging integration similar like production, because they were so expensive. Now we all in production. Like I see that as benefit. It's just different account, limits to different things.
Yeah, the issue, I guess if you were to use the stages within the Lambda, you get quicker deployments on some level. And then you've got, there's a little bit of like traffic sharing now they've built into it. So you're foregoing that by using this pattern. But again, the upside is this notion of, and one of the reasons why some of the companies that we work with, that when they're a reasonable size, they end up sort of liking what we do with Seed. And this isn't specific to Seed necessarily. This is just like serverless framework, is that each of these guys that you get, each of these environments that you get are completely standalone. And so if you've seen sort of the serverless framework, and I skipped over this, you can set the stage in there.
Just want to add one note that deploy is kind of like a full deploy, like you're spinning up an app server, right? So it's not as inefficient as it would imagine.
I mean, do you mean like efficiency in terms of cost, or like just like we're using too much?
You can have a lot of dependencies in your system, right?
Mm. Mm.
Has to happen at the same time. You really cannot count on things picking up themselves. If you have individual lambdas, you can actually let the lambda fail and keep failing for the next 15 seconds when you deploy. If you deploy 25 lambdas, you can't really do it.
Right.
Cascading effects everywhere, and you don't really seamlessly operate your system. So this is kind of something to do. Maybe you are just not thinking right.
Right. Right. Yeah. Sorry, go ahead. Yeah.
Actually, I have one more question.
Yeah.
Have you guys come up across any library that efficiently keeps lambdas working? So some of our lambdas are so small that we don't care. But some of our lambdas actually take about 20, 40 seconds to run up because we're loading expensive libraries.
Mm.
Beyond other performance like graphics processing, OCR and stuff. So we have absolutely no control over those.
Yeah.
We want to keep those warm.
Hello?
Yeah.
One story to keep one lambda warm.
Right.
It's another story to keep 12 instances of at Lambda work, right? So have you guys?
Yeah,
Just curious.
no, we don't quite use it with Seed, but there are a few libraries out there. I think the tricky part that you run into, so to sort of elaborate on this cold start issue is that you've got some Lambdas that take some time to come up, and the trick people use is they warm them, which is basically just another Lambda that runs on a schedule. Every 5 minutes will ping this Lambda that you want to keep warm, so the container is always sort of up. And because you're only being billed for the amount of time it takes to execute your code within the Lambda, which for the warming portion should be a really small part, this ends up being a relatively okay strategy in the sense that you're not being billed for the entire time that the Lambda is being kept warm. The issue that you run into, and Frank was sort of explaining this, is that you need to be able to essentially say how many concurrent versions of this that I need to keep warm. So you're almost like you're trying to manage a pool. So you're assuming that I would just need maybe 4 or 5 Lambdas at the same time. So it's just, again, the model here is if you're pinging your Lambda once every 5 minutes, there's only one guy that is up there that is warm. And if you have 5 users that come in at the same time, one of them will get the warm one, but all the 4 or the 4 rest of them will have to bring up another one on their own. And so, yeah, so there isn't like a great strategy. I think the best thing that we've sort of heard about this really is that going into next year, that is the big point of emphasis for AWS, is reducing the cold start times. Because at the end of the day, the real sort of magic sauce behind Lambda is just that part. And I think he had a question before about how are they able to keep it so fast, and that's really what they're trying to solve. So there isn't a good library, and I think, yeah.
Yeah, but I don't think it's that super hard to build something on your own, because for each Lambda, when it executes, you know if it is warm or if it is cold, right? So it's almost like handling like PHP pools and MySQL pools, right? You probably have better knowledge on your traffic patterns than Amazon knows, right? And so you can pretty much write a library. Let's say when a Lambda runs, it kind of quickly pings your server saying, okay, I'm cold, and you know, okay, I think we're running low on containers. Let's spin stuff up more, and each Lambda has like a temporary like 500 megabyte disk storage. You can set some temporary flag on there, saying like how many requests have been handled, and am I cold or am I not? And you can assign each ID, so you can actually trick the system where you can write an ID, store like a file, put some like random string in there, and in your server you can track, okay, what is the ID that just handled this Lambda execution, and you can manage a pool of IDs, and if they're running low, you can spin up more. If it's not using as much, then lower the threshold. Yeah, something definitely you can do them, but there are cases where Amazon just randomly turns off your Lambda because they need to do some maintenance. But there's no way to get around that. But that doesn't happen very often.
Yeah. So essentially, Frank is like, go home, write it yourself. Here's some pseudocode, you know.
Presumably, there's only a few functions which are really time sensitive. Maybe it's all, but for example, you could have a Kubernetes container or an EC2 instance running to actually run the most time sensitive, and then Lambda is there for the things that are responding to event queues, responding to SQS, responding to the message bus, and all those other types of things. But maybe not. I don't know your app.
Yes.
That's a problem with every new technology. Like we see, like when every problem, like when only tool you have is a hammer, every problem looks like a nail. So don't force it. Like pick the use cases carefully. Like you will see in the first presentation slides that we gave some ideas. Mostly non-time sensitive jobs, non-life and death situations. Like there's so many batch jobs that you can play with. So.
You had a question, yeah.
My question is related mostly to for people who use the old style where you
Cobra,
update.
you mean?
No, I'm more like you have a dev environment where you update
okay.
everything and release it, make sure you test it and everything
Yeah.
else. This now is being handled by Amazon. We are like, I'm assuming in the background they're updating all the security patches. Have you ever run into an issue where you had all of a sudden one day, after some update, your app didn't work, and you had to?
Is specifically for the Lambda, you mean?
More like for Node.js, for example. Yeah.
So they don't. So yeah, Amazon is very picky / slow and thorough, I guess, on this. So the last update that they did to Node was really just 8.10, which was February, maybe, I think. Prior to that, it was 6.10 forever, and people complained about it. They finally did 8.10, and we're like, 8.10, really? We'll move past that. So yeah, so they haven't really. It's 8.10, 6.10, 4 point something, which is being phased out now. And yeah, so they don't update that very often, yeah.
So they leave all the security issue.
Yeah,
to
yeah.
figure
The security.
Pin each Lambda to a version. They won't just change it.
Yeah.
Every Lambda that you define.
Even,
Yeah.
Say this runs at 8, this runs
Yeah.
even the minor numbers, they don't change.
Yeah, no. Yeah, they don't touch them, yeah.
Just want to make
Yeah.
sure.
Which is maybe why they're so slow in updating them, It's
Well, I wanted to say something that I found interesting, something I learned.
Yeah.
And you guys did a really good job of demonstrating that architecture is when you could talk directly to those specific products and services in AWS, when you look at the way they bill you, for example, S3 bills you on ingress, egress, right? Lambdas on everything, Dynamodb on specific things, Cognito on not storage, but like again, how many logins I think it is. So you can really, when you get rid of that app server, you can really drive your costs down big time. And if you're going to use Lambdas to proxy through those servers, you're going to increase latency and you're going to increase costs too, because Lambdas are probably the most expensive piece of the puzzle. Just wanted to share that.
Yeah, it's a good point, because you get this feeling sometimes where you're like, oh, but I don't feel comfortable letting the client talk to all of these things, and so you want to front it with a Lambda or an API gateway instance, and yeah, the way these services are designed now, and they're moving towards, and they started moving towards it. Really, again, if you guys remember, S3 was the first thing that came out of AWS, and they've had that. They've had that way of thinking for a really long time, where each of these guys are not meant to be used in conjunction the way we've drawn it up here. They were designed on their own, right? They're serving their own set of customers, and that's where you get a little bit of the sort of design flaws of AWS as a whole, where these are designed by almost siloed teams on their own. So they might not work terribly well, like they're not tightly integrated with each other. But again, the billing aspect, they're thought of as their own services. And so, yeah. So when you're thinking about cost, you're really thinking about using the specific services themselves, not so much so that, hey, I put a Lambda in front of each one of these guys. Cool.
So to tie into that one, it's interesting. I think the future, what's going to happen first, so shift away from application servers that you're okay, you're allowed to talk to other guys as long as you're secure. Security is must, but that's taken care of. And the second thing that you touched about cost and billing, like there used to be job systems engineering kind of that you're making sure it's highly available, scalable. Now that's taken care of, but there's going to be jobs cost engineer, because they may be the same thing done 3 ways and you will be optimizing on cost. For instance, like in Lambdas, like you don't want to wait, you're built for that. But there is a step function that doesn't cost you anything to wait. So you'll be tying in, like that's kind of my prediction for next few years.
Yeah, it's funny, we did that. we did some cost optimization over the last week. And it's a stark contrast to a few, like maybe a decade ago or so, where, it's not a decade ago, but like 5 years ago or so, when you looked at your Amazon thing, it was really just like EC2 and EC2. Well, there was S3, but you would ignore S3 because unless you're uploading a ton. But now it's just like, oh, there's so many services, and you have to kind of project costs based on each of those services. And yeah, there is something there where like you have to start thinking about managing costs on a service level as opposed to your entire thing.
HR, what for those jobs?
Yeah.
Just curious, like I noticed that you can use Lambdas also with GraphQL. This is very much like your standard. Yeah, you can use Lambdas with GraphQL. I've never like tried that. I'm curious if you have any experience. This has very much been more like your standard REST focus, but a lot of stuff is shifting into just requesting what you need on the front end. So do you have any thoughts on that?
Yeah. So big. If somebody gets a chance to sort of do this and explore this, AppSync has been the big piece that's gotten a lot of traction and popularity. This is again sort of a GraphQL piece that sits in front of Dynamo essentially, and yeah, you get most of the GraphQL bits out of it. It's still very new. From some of our friends that are using it in production, they're still sort of working through issues. So I'm not personally comfortable pushing it into production just yet, but it's definitely one of those things that, like, once you start sort of using it, maybe it ties this together in a much better way than just a simple REST sort of system. So AppSync is probably
AppSync. So one more thing around there. I posted in the main page for invite 2 links. One is Joe something Emerson. I forgot his last name. Second link. So he shows 4 use cases in serverless. One of them is AppSync. He was ecstatic about the server, and I believe him because he used Firebase before. So I saw AppSync and GraphQL as kind of response to non-Google world to have real-time updates to mobile. So kind of making live database and simplifying life. He loves it. So just listen to the use case he had and then dive in. I don't have experience with that. You will see. So go to the main event page, past events. I posted at the bottom homework how to prepare to watch Goiko's talk because he. And then the second one is Joe's talk. Like, you will love it, and that will open your mind for creativity. Like, you're gonna. So just don't think as a developers, because you're going to do less work, but then as a business owners, as creators, architects, your hands will become free to do more. So it's like giving you leverage. And also, like, if you're new to cloud, like the precursor for this is to move to the cloud. Pick up any book, anything for cloud. Just kind of get the language barrier out because, like, Lambda is not so new thing. It's built on the containers and then it's built on the cloud. So you have to get familiar with those two terms first.
Thank you. I have a question about the troubleshooting. Say in the 3-tier architecture, we can log in the virtual machine instances to troubleshoot. So for serverless, what's your best practice?
Well, there's no login anymore. Oh, no, sorry. There is a login into your AWS account. Yeah, I'll be honest. So prior to coming here, we were sort of working on some stuff, and we tend to get a bunch of questions around the tutorial, and people have issues. Like they make their first request, and you get a 500 error. And now you're like, what? Like, where do I, which point is it failing in? And that's kind of the funny part. And this hasn't been done all that well just yet. So you could have a point of failure here, a point of failure here, a point of failure here, or a point of failure here, or your Lambda just sucks, right? Like you could fail in all these different spots. And so troubleshooting is a bit of a problem. You end up leaning heavily on CloudWatch for logs. X-ray is another topic that if somebody gets a chance to probably touch on. It helps you draw out what it looks like, the request looks like all the way through all the services, so you can visualize where it's going through. But yeah, no, it is a good point, and it's not one of Amazon's greatest sort of strengths where they make this easy to do. And so it's not great yet. Like the developer experience around troubleshooting systems like this isn't great just yet. But the good news is you don't necessarily run into, because you're able to replicate your production environment almost one-to-one because you're able to bring up the entire stack, you have a chance to essentially test some of these at a level where hopefully if it's running in staging, it's going to run okay in production. Whereas in the past, like you might have other type of issues where, like you've got some problems that you run into with your app server only at a certain amount of load or under some really weird conditions. Like I remember there used to be bugs around, people would have cron jobs and there would be some sort of a bug there. And so you'd only see these errors pop up at a certain point at night every single time. And so those type of things don't necessarily happen with this type of thing. But the issue that you run into is you have to trace these guys. So you have to figure out where they're failing. So.
Thank you very much.
Anybody else? Still have time. You're awfully quiet.
Like I've only used Lambdas like wrapped around. They've been wrapped by another service. Like I used Netlify, which I don't know if you're familiar with.
Yeah.
But they kind of give their own functions. If you're just using it directly through AWS, or maybe you're using serverless, like the framework.
Yeah.
When you're developing locally,
how does that work for like actually writing and using the functions locally before you deploy them, especially if you have to lock down certain permissions through cores or like whatever how does it mimic those things?
Yeah, it doesn't quite mimic them all that well. So the way you sort of do this, there are different sort of levels of ways you can sort of kind of do it. And the way we do it in the tutorial and a common pattern is like you write up this Lambda, but you haven't deployed it yet. So it's just like this function on your computer. And serverless has a command, and the other frameworks have this as well, where it'll just invoke it locally for you. So this is just a command in your terminal that you're running, and it just runs that function locally for you. Then there is the ability. There's a plugin called Serverless Offline, which we sort of touch on, but that will run a local server or an API gateway server for you. So you could, let's say in React or whatever else that you're using, you could connect to localhost something, 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 and treat it sort of similarly. But it can't quite mimic all the things all that well, right? Like the IAM portion is just not going to happen. That's just happening for you at a local level. But again, I think the advantage of this is so again, the way you would sort of do this is like, you've done this stuff on local, you've talked to it locally, you've invoked it locally, you've used the local server. Once you deploy it up, hopefully you're deploying it to a dev or a staging environment, and maybe then you plug in your front end into an actual URL, like an HTTPS, some obscure AWS URL, and you test it with that. You might run into some issues there. But once the connection is sort of solid there and you have that up and running, if you were to promote that or if you were to deploy it again into production, you should be fine. So that part, I think, works out. That part translates relatively well. What doesn't translate very well is these IAM pieces on your local, essentially. So, yeah.
Should we do the draw?